All right, today we are going to look at the rational functions part 1 review sheet. Again, I will do this how I normally do. I'll go through and do one of each type, and then I will go back to the beginning and finish working through them. All right, so this was a pretty quick unit. We did variation, graphing, and then we talked about simplifying and multiplying and dividing rationals. So if you look at 1, 2, and 3, these are all different types of variation. We are going to solve for k. We are going to write the equation, and then we are going to use that equation that we found to find a specific solution. So if it says y varies directly as x, we know that this is the equation for direct variation. It also tells me that y is 15 when x is 3. So the first thing I want to do is I want to be able to solve for k. So I'm going to divide both sides by 3, and I get that k is 5. Now when it asks me to write the equation, I want to go back to that direct variation equation and fill in what I just found for k. So I get y equals 5x. The solution part is saying find y when x equals -4. So I'm going to take that equation that I have, and I'm going to replace x with -4. So y ends up being -20. All right, number 2, we have y varies inversely as x. So this time, this is my variation equation. Again, we need to find that k, that constant of variation. So it's telling me that y is 8 when x is -2. So I'm going to go ahead and replace that. To get that -2 out of the bottom, I'm going to multiply both sides by -2. So -16 equals k. Equation, I'm going to take that inverse variation equation and replace k with what I just found. So I get y equals -16 over x. All right, now it wants me to use that equation to find y when x is 3. So I can go ahead and rewrite that as a decimal. -16 divided by 3 is going to be -5.3333. So -5.33 repeating. Okay? You can also leave it as a fraction if you want. All right, 3 says that z varies jointly as x and y. So joint variation looks like that. And again, we need to find that k, that constant of variation. So we're told that z is 56 when x is 2 and y is 7. So 56 equals 14k. I'm going to divide both sides by 14. So k ends up being 4. Again, equation, you're going to rewrite it and plug in what we just found. Now, the solution, it wants me to use this equation to find z when x is -1 and y is 8. So 4 times -1 times 8 gives me a -32. All right? All right, so those are 3 variation problems. Number 4 is another inverse variation, and we'll come back to that. All right, 5 and 6, we are graphing rational functions. Remember that we take our parent function and we talk about the different transformations that were being made, and we shift our graph. So if I look at this one, this negative is going to be a reflection over the x-axis, and then it's going to be stretched by 5. So since I did not shift my graph left or right at all, that means my asymptotes are in the exact same spot that they are on my parent function. So my horizontal asymptote is still at y equals 0, and my vertical asymptote is still at x equals 0. All right, so let's fill in our graph. Once we find our intersection of our asymptotes to get our left-hand points, our left-hand man points, typically we would go to the right one and then up the number that we're stretching by. But since we are reflecting, we're going to go to the right one and then down how many we're stretching by. Over here we're going to go left and up. And then we know that our asymptotes are there as a guide. So our graph hugs those asymptotes. Now, domain and range, you have a choice. You can write it in set notation or interval notation. I'll do one of them in set and one of them in interval. This one I'll go ahead and do in set. So domain and range are all real numbers, except for domain, x cannot be 0, and for range, y cannot be 0. All right, number 6. This time let's look at the different transformations that are being made. So you're stretching by 3. You're moving to the right 2 and up 4. So when you shift your graph left, right, up, down, that shifts your asymptotes left, right, up, down. So if I'm going to move to the right 2, that means my vertical asymptote is now at x equals 2. If I'm going to move the entire graph up 4, that means my horizontal asymptote is now at y equals 4. Now, I find my intersection of my asymptotes and I graph my left-hand man point. So I'm going to go to the right one, up the number I'm stretching by, so 3, and then I'm going to go left one, down the number I'm stretching by, 3. I know that my asymptotes are there as a guide, so my graph will hug that. Now for domain and range, I'm going to go ahead and write it in interval notation. Remember that when I write interval notation, I have 2 separate domains and ranges, and it breaks at those different asymptotes. So for domain, it's going to go from negative infinity to 2, and then 2 to positive infinity. For range, it's going to go negative infinity to 4, and then 4 to infinity. Okay? Alright, let's look on the back. So 7 and 8 are more graphs, so we'll come back to those after we've gone through the rest. Now 9 is, given the parent function, can you rewrite the equation given the different transformations that are being made? So we want it to be shifted right 3 units, up 2, and stretched by 5. So we know that a stretch is going to go in the numerator. If we want to shift right 3, then that means it does the opposite of what it looks like. So I'm going to say x minus 3. To shift up 2 units, I add 2 at the end. Okay. All right, 10, 11, and 12 want to know what type of variation is being represented and name the constant of variation. So on number 10, I have y equals 1/8 x. This is direct variation. And right here is my k, so 1/8. 11, because I have a variable in the denominator, this is inverse. And k this time is 20. 12, I have 3 different variables, so I know that this is joint, and k is 14. All right. All right, on 13 and 14, you are given the equation of a rational function. You are asked to find where the horizontal and vertical asymptotes are. So remember that if I shift up or down, that changes my horizontal asymptote. So right here, you're moving up 4, which means your horizontal asymptote is going to be y equals 4. If you move your graph left or right at all, that moves your vertical asymptote. So right here, this is saying move to the right 5, which means your vertical asymptote would be x equals 5. Okay? All right, let's flip to the next page. These are simplifying and multiplying and dividing your different rational functions. So typically when we are multiplying, dividing, or just simplifying, there is going to be factoring involved. So for example, right here, I have 4x squared minus 8x. This is a GCF problem. I have two terms, and they both have a variable and coefficients. So if I look at 4x squared minus 8x, they both have a 4x in common. And if I factor that out, I'm left with x minus 2. Now down here in the denominator, I have this negative in the front. I'm actually going to distribute that negative through to this parentheses. So a negative times a 2 is going to give me a negative 2. A negative times a negative x is going to give me a positive. Now I know in that form it's a little hard to see, so I'm going to rewrite one more time. And this is really x minus 2. So when I try to simplify, I'm looking for like terms in the top and in the bottom so that they can be reduced. X minus 2 over x minus 2 is really just 1. Right? So they can be simplified out and just become 1. 4x over an x squared, remember that an x squared in the denominator is really saying an x and an x. So one of these x's reduces with that x, and I end up with 4 over x. Okay. You can also use your exponent properties right here. I have x to the 1 over x squared, which if I subtract is going to give me an x to the negative 1. But I know that negatives have to go into the opposite position because they're traders. Think back to your pink book. Then I know it still goes to the bottom. Okay. We can go ahead and do a 16. It's pretty easy. This one is already factored for us, which is nice. So again, I'm looking for like terms in the top and in the bottom. So right here, even though they're not directly above each other, I have an x minus 5 and an x minus 5 that give me 1. So I end up with x plus 8 over x minus 9 as my answer. All right, 17. 17 we're going to have to factor. This time these are trinomials. So I'm looking for what multiplies to give me 24 and subtracts to give me 2. So if you're not sure, remember that you can always come over here to the side and list your factors of 24. Okay, and again, I'm looking for the 2 that subtract to give me 2. So I've got 4 and 6. My middle term is positive, which means my larger factor takes that sign. So I've got x minus 4 and x plus 6. Now we need to do the same thing down here. What multiplies to give me 6 and adds to give me 7. Again, if you're not sure of your factors, then come over here and list them. I've got 1 and 6 and 2 and 3. I'm looking for the 2 that add to give me 7. So I get 1 and 6. Because this is positive all the way across, these are positive all the way across. Again, once it's factored, I'm looking for like terms in the top and in the bottom so that I can reduce them. So if I look at this one, they both have an x plus 6 that reduced to 1. So I'd be left with x minus 4 over x plus 1. Okay. 18, the numerator is a DOPS problem, because I know x squared is a perfect square, and I know 36 is a perfect square, and I'm subtracting in between, so it's the difference of perfect squares. So I know I have a plus and a minus. The square root of x squared is x, and the square root of 36 is 6. Right. If I have x plus 6 squared, that really means I have x plus 6 2 times, so I'm going to rewrite it. And then I'm going to look to see if they have any like terms in the top and the bottom. They both have an x plus 6 that reduced to 1. And I'm left with x minus 6 over x plus 6. Okay? Alright, so on 19 through 24, it's still the same idea. You're simplifying, but you're also adding an additional operation to this. So you might be multiplying or dividing first and then trying to simplify. So on 20, you are dividing. So remember that division with fractions means that we are really multiplying by the reciprocal. So I'm going to flip that second one. Now in problems like this where they are not factors. I don't need to figure out the trinomial or the binomial. I'm going to use my exponent rules. So the first thing I'm actually going to do is I'm going to look at my coefficients. So I've got a 2, a 7, a 21, and an 8. I want to see if any of those can be reduced before I multiply out. When I do that, I look cross. So 7 and 21 can be reduced to 1 and 3. 2 and 8 can be reduced to 1 and 4. That'll make my numbers a little smaller. Now I'm going to actually multiply across. So I have x squared times 3y squared. So 3x squared y squared. In the bottom, I have xy times 4xy to the fourth. So I have 4, x and x gives me an x squared, y and y to the fourth gives me y to the fifth. Now I'm going to use my exponent rules. I have an x squared over an x squared, so 2 minus 2 gives me 0, which means my x's reduce out. But I have a y squared over a y to the fifth, so if I actually subtract these, then I would get a y to the negative 3. So I have 3/4 y to the negative 3. But remember, we don't leave negative exponents, so it always moves to the opposite spot, so it's going to go to the bottom. Okay. All right, on 21, this one is actually a factoring problem, so you might have dots, GCF, trinomials. So before we just multiply straight across, we want to go ahead and factor this to see if I can simplify anything out like I did with 15 through 18 before I multiply. So x squared minus 49 is a dots problem, so I know that I have a positive and a negative, and the square root of x squared is x. The square root of 49 is 7. Over here I have a trinomial, so I'm looking for what multiplies to give me 36 but adds to give me 12. So remember, if you can't remember, come over here and write out your factors of 36, and again you're looking for the two that add to give you 12. So I have x plus 6 and x plus 6. Sorry, I ran out of room. On the bottom I have x cubed minus 7x squared. This is a GCF problem. They both have an x squared in common, and then you're left with an x minus 7. Now, before I multiply across, or even if you want to go ahead and multiply across, I'm looking to see if there are any terms that can be simplified so that I don't have so many at the end. So I'm always looking for in opposite spots or opposite positions. So do I have something in the top that matches something in the bottom? It doesn't matter if it's on the other side of this multiplication, because if I were to multiply them, they'd all end up together. So right here, I have an x plus 7 and an x plus 7. Here, I have an x minus 7 and an x minus 7, which leaves me with an x plus 6, x plus 6, over x squared. Okay? Alright, on 22, again, we need to factor as much as we can, but before we do that, since we are dividing, we need to go ahead and make that adjustment. So dividing with fractions, the same thing as multiplying by the reciprocal. So let's go ahead and flip that second one. Okay? And now we're going to try to factor as much as we can. So 6x squared minus 18x, that's a GCF problem. It's a binomial, and they both have an x, at least an x. So I'm going to go ahead and take out what they have in common. So 6 and 18 both have a 6 in common. X squared and x have an x in common. If I take those out, I get x minus 3. And then I still have an x in the bottom. And then let's come over here. I have x squared minus 8x plus 15. So I'm looking for what multiplies to give me 15 and adds to give me 8. Remember, if you can't remember, come over here to the side and write your factors. So the two that add to give me 8 are 3 and 5. Now, it multiplies to give you a positive 15 and adds to give you a negative 8, which means these are both negative. Now, before I multiply across, I want to see if I have any like terms in top and bottom. So right here, I have an x and an x, so those simplify. And I have an x minus 3 and an x minus 3, so those simplify. So in the top, I'm left with a 6 times 9, which gives me 54. And in the denominator, I'm left with x minus 5. So that becomes my final answer. Okay? All right, so that was one of every type of problem. So now I'll go ahead and go back to the front and finish working through the rest of the review. All right, number 4 is a variation problem again. It is inverse, so it's telling us that the current varies inversely with resistance, so C equals K over R. It says if the current is 50 when resistance is 4.5, find K. So current is 50 when resistance is 4.5. So to get rid of the 4.5, I'm going to multiply it on both sides. So 50 times 4.5 is going to give me 225. So that is my K. Which means if I rewrite my equation, it's C equals 225 divided by R. Then we want to find the current if the resistance is 6. So current is 225 divided by resistance. But what if we say that the resistance is 6? What would the current be? So 225 divided by 6. So, current ends up being 37.5. Okay. All right, let's go ahead and turn the page and we'll look at 7 and 8. So these are 2 additional graphing problems. So let's talk through the transformations that are being made. So this 2 on top is a stretch by 2. And the minus 3 is going to move it down 3. So remember, if you move left, right, or up or down, that is going to change those asymptotes. So since you're moving down 3, your horizontal asymptote is now at negative 3. You didn't move left or right at all, which makes your vertical asymptote still at 0. So your horizontal is at y equals negative 3, and vertical is at x equals 0. Once I have the intersection of my asymptotes, I'm going to find my point. So I go to the right one and up how many I'm stretching, so 2. Left one, down 2. And then I hug my asymptotes. And again, domain and range, you have that choice. So set notation, all real numbers except x cannot be 0. All real numbers except y cannot be a negative 3. Okay. On number 8, I have 1 over x plus 4. So the only transformation that is occurring is that you are moving left 4. So if I move left 4, that moves that vertical asymptote, but your horizontal stays at 0. So your horizontal is still at y equals 0, vertical is at x equals negative 4. You're not stretching, so when I go to plug this in, my intersection of my asymptotes, right one, up one, left one, down one, and again, use those asymptotes as your boundary line. Now domain, I'm going to go ahead and use my interval notation. So negative infinity to my breaking point of negative 4, and then negative 4 to infinity. Same thing with range, negative infinity to the breaking point at 0, and then 0 to infinity. Okay. So those are your graphs. All right, we have number 14 to finish on this page. So given the equation of the rational function, we just want to find the asymptotes. Right here, this is telling me to go down 3, which means my horizontal asymptote is now at y equals negative 3. This right here is telling me to go to the left 1, so my vertical asymptote is at x equals negative 1. All right, we have 3 left on this side, so we're going to look at number 19. Oops. So on 19, this is another problem like 20, except I'm multiplying this time, so I don't need to flip that second one. But again, the first thing I'm going to do is I'm going to look at my coefficients, my numbers, to see if there's anything I can simplify before I have to multiply through. So 9 and 3 reduce to 1 and 3, and 7 and 35 become 5 and 1. Now I'm going to use my exponent rules, and I'm just going to combine. So over here I have x cubed y times 3x squared y. So 3, an x cubed and an x squared is going to give me an x to the 5th. A y and a y is going to give me a y squared. In the bottom I have y cubed times 5x cubed. So 5x cubed, y cubed. Now I'm going to use my exponent rules. So an x to the 5th over an x cubed, if I subtract 5 minus 3, I get a 2. So I'm going to end up with an x squared. I have a y squared over a y cubed, so if I subtract those, I end up with a y to the negative 1. Last step is if I have any negative exponents, go ahead and fix those so that y is going to move to the bottom. Okay. Alright, we've got two more, 23 and 24. So on 23, I have a division problem, which means first thing I need to do is go ahead and multiply by that reciprocal. So I'm going to rewrite these. Okay. Now I'm going to factor anything that I can. So this top one is a trinomial. So what multiplies to give me negative 27 and subtracts to give me 6. So if you can't remember your factors, then go over to the side. And I'm looking for the 2 that subtract to give me 6. So I've got 3 and 9. My middle term is negative, which means my larger factor is negative, so the x minus 9. The 2x squared plus 2x becomes a GCF problem. They both have a 2x. So I'm going to go ahead and bring that 2x to the front, which will leave me with an x plus 1. Over here, my x squared stays the same, and then I have x squared minus 14x plus 45. So what multiplies to give me 45 and adds to give me 14? So remember, we can say 1 and 45, 3, 15, 5 and 9. So 5 and 9 add to give me 14. So x 9. They multiply to give me a positive 45, but add to give me negative 14, which means these are both negative. Now, before I multiply anything, I'm going to look to see if I have like terms in the top and in the bottom. And if I look, I have an x minus 9 and an x minus 9. I have an x and an x squared. So this x just gets rid of one of those x's, which means I'm left with an x plus 3, 2, x plus 1, x minus 5. Okay? And if I look, and I'm not sure if I have simplified everything when it's in this form, once I've multiplied them together, if I look to see if there's still any like terms, I could simplify it a little bit further from there. Alright, 24, we are multiplying, so let's go ahead and factor these. So 3x minus 12 is just a GCF problem. They both have a 3 in common, so I'm going to go ahead and factor that 3 out. X plus 5 is in its simplest form, so is x plus 6. 2x minus 8, they both have a 2 in common, and when I do that, I'm left with x minus 4. So now if I look to see if I have any like terms in the top and the bottom, I see that I have an x minus 4 in both. Now I'm going to go ahead and multiply across, so I have a 3 and an x plus 6, and then in the bottom I have a 2 and an x plus 5. And that is in its simplest form.